Welcome to a refresher lesson for quadratic functions graphing. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. So when we are dealing with quadratic functions and we are trying to graph a quadratic function, we again need to understand that quadratic functions can take three different forms: the standard form, the vertex form, and the factored form. And depending on which form our quadratic function is in, will dictate how we go about doing our graphing. It'll be a little bit different for each of the different forms. One thing to make note of before we get started is that you'll notice in all of our forms, we have an a value. So we have the a here in front of the x squared in standard form. We have the a here in front of the parentheses that are squared in the vertex form. And we have the a here in front of the first parentheses of the factored form. In all three cases, that a can tell us some things about the characteristics of the graph we're going to be graphing. First of all, if our a is positive, then we know that our parabola needs to open up. So remember, a parabola is just that U shape that the quadratic function is going to take. So if we know that the a is positive, then we know that that parabola, that U, is going to open up. If the a is negative, then we know our parabola will open down. So that's something to be looking for when you're graphing to help you make sure that the points you are plotting seem accurate based on the a value that you are looking at. Another thing that the a can tell you is sort of how wide or how narrow your parabola is going to be. So if you take the absolute value of a, meaning that we're looking at the a value and we don't really care if it's positive or negative, if that value is greater than 1, then your parabola is going to have what's called a vertical stretch. And if you take something and you stretch it up and down, then what's going to happen is you're going to end up with something that's narrower than what the usual y equals x squared graph would look like. On the other hand, if that absolute value of a, so again, not really paying any attention to positive or negative, but if that absolute value of a is somewhere between 0 and 1, so it's a fraction that's between 0 and 1, then we say your parabola has gone through a vertical shrink. So it's like you're pressing down on it from the top and the bottom. And when that happens, you end up with a parabola that is wider than what you would normally get with a y equals x squared graph. So these are just some things to think about that can kind of help guide what we're going to be doing with our actual graphing. So let's take a look at the vertex form first. Generally speaking, when we are graphing quadratics, the first thing we want to look for is the vertex. And then we usually want 4 additional points beside the vertex to get an idea of which way it's going to open and just how wide or narrow the U shape is going to be. Okay. Well, the nice thing about the vertex form is that you can tell the vertex directly from the form of the equation. Your vertex is going to be the h value, comma, the k value. So remember, in the vertex form, our h is the value that's inside of the parentheses, and our k is the value that is outside of the parentheses. Something to be careful about, though, is that when you're looking at the h value, this negative sign, that minus sign, is already part of the structure of your function. So when you look at something like an x minus 4 being squared, our h value is just a 4. The minus there is part of the structure of the vertex form. On the outside, our k value is what it looks like. Plus 3 is a positive 3. Okay? And then also notice our a value is a positive 2. So from this, we just kind of know that as we are graphing this, we should be looking for a parabola that opens up and one that's going to be a little bit narrower than normal. Okay, so from our h and our k value, we know our vertex will be the point 4, 3. Now, in our graph, we know this is our x-axis, this is our y-axis. With a 4, 3, we're not really sure what kind of scale we should be using. So before I really think about this, and I can go ahead and do 1, 2, 3, 4, 1, 2, 3. I can go ahead and put it here for the moment. But then as I look for these 4 additional points, I may realize that the values are too big to fit on my graph if I go with a scale of 1. And so I may have to adjust my scale later. Okay, so let's look at some other points. When you are looking for points, you want to remember that parabolas have symmetry. And the symmetry is across what we call the axis of symmetry, which is a vertical line that goes through the vertex. So whatever points we have on the right side of our vertex, of this axis of symmetry, they will be reflected to the left side of this axis of symmetry and vice versa. And so we can use that to our advantage. So we are going to take a look at some x values that are close to our vertex on one side of the axis. Now, I tend to like to use smaller numbers rather than bigger numbers. So I'm going to choose an x value of 3 and an x value of 2. Okay, so those are 2 values, both to the left side of our axis of symmetry. So when x equals 3, I'm going to substitute that into my equation. So 3 minus 4, quantity squared, plus 3. So 3 minus 4 is a negative 1. When I square that, I get a positive 1. And then 2 times 1 will be 2, plus 3 is going to give us a 5. So I know one point is the point 3, 5. When x is equal to 2, if I do the same thing, substitute the 2 in for x. Now I have 2 times 2 minus 4, which is negative 2, squared, which will be 4. So 2 times 4 is going to be 8. 8 plus 3 is going to give me 11. So I have another point at 2, 11. Now notice here, this 11 is not going to fit on my graph with a scale of 1. So I'm going to go back to my graph here for just a minute. I'm going to clear this axis and that vertex, and I'm going to change my scale so that we have a scale of 2. Okay, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, and then the negative direction as well. Now, you do not necessarily need to label every one of these lines, but you do need to label something to show what kind of scale you're using. So now if I go back to my vertex and I plot 4, 3, I'm going to plot that point right here using a scale of 2. This is my new vertex. And then I'm going to plot my 2 points here. So 3, 5. So 3 is halfway between 2 and 4. 5 will be halfway between 4 and 6. So that's going to give me a point right there. And then 2, 11. So 2 is right on that first line. And 11 will be halfway up from 10 so that I get that. Now again, remember we have this axis of symmetry that runs right through the vertex. So every point I just plotted on the left side, I can now reflect to the right side. So 1 unit away this way means I can go 1 unit away this way and I have a point here. Half a unit this way means I go half a unit this way and I have a point here. Okay. And so I can get my 4 additional points by really only having to figure out 2 points and then using the symmetry to come up with the other 2 points through reflection. And now I can draw a smooth curve through those points. And I get a parabola that looks something like that. Okay. Now, just to reinforce this idea of using the structure of the vertex form properly, if we are looking at this equation, y equals x plus 3 quantity squared minus 1, and we're trying to identify our a, h, and k values, our a value is going to be a 1, because remember, anything, if there isn't anything out in front of the parentheses, we're really just multiplying by a 1. My h value now, since I have x plus 3, that must have meant that I was taking x minus a negative 3 in order to get the x plus 3. So my h value is actually a negative 3 in this case. And then my k value would be a negative 1. And then you would go through the same process that we did before. We would have our vertex at the point negative 3, negative 1. So that would be right here if we use a scale of 1 for the moment. And then if I decide to use x equal to negative 2 and x equal to negative 1, when I put negative 2 into my equation, negative 2 plus 3 is 1, 1 squared is 1, minus 1, that's going to give me a 0. So negative 2, 0 will be a point. Okay. And then with negative 1, same thing, substitute that in. Negative 1 plus 3 is 2. 2 squared is 4. Minus 1, that's going to give us a 3. So this will be negative 1, 3. So all of these numbers fit pretty well on a scale of 1 with the graph that I have. So there's our negative 1, 3 point. And then I'll use reflection for these 2 points. And then draw the smooth curve. And there's your parabola. All right, let's take a look at factored form. So with factored form, we are now looking at A, P, and Q. So again, nothing out in front of the parentheses, which means A is just going to be 1. The p-value, remember our general form for factored form is that y equals a times x minus p times x minus q. So again, the minuses are part of the structure. And so the p-value in this case for x plus 2 to have come from x minus something, that something must have been a -2. So we have a -2 for p, and then here our x minus 4 means that the 4 is the q value. Okay. Now, in factored form, what that means is if I take my function and I substitute -2, whoops, sorry, the -2 in there also. So I substitute the -2 in for x. Here, my factor becomes 0. So I end up taking 0 times the -6, which means my y is just going to be 0. Similarly, if I'm subbing the 4 in, I would have a 4 plus 2, and then a 4 minus 4. Now it's this factor that becomes 0. And so y is also going to be equal to 0. So from your p and q values, what you are really getting are the x-intercepts, which are also sometimes referred to as the zeros of the function or the roots of the function. But in our case, we're really just interested in them being the x-intercepts. So at -2, I can put a point, and at +4, I can put a point. Okay. Now, let me erase some of that so we have some room. Oops. Sorry about that. Okay, I'm not sure why that's being so fussy, but we'll get it here. There we go. All right, so we know that our A is 1, our P was the -2, our Q is the 4. So we have x-intercepts at the moment at -2 and 4. Okay, but now what about the vertex? Well, in order to find the vertex, we need to find the x value for the vertex. And the x value is going to have to be something that is halfway between our two x-intercepts. Again, because our axis of symmetry has to go through the vertex, and our parabola will have symmetry across the axis of symmetry. So that line has to be halfway between the two x-intercepts. And the x value that that line is on will become the x value of our vertex. So the easiest way to do this is to take P plus Q and basically find the average of them, divided by 2 to find the halfway point. So that means our x is going to be a -2 plus 4 divided by 2. -2 plus 4 is 2 divided by 2, so that's going to be at 1. Now, to find so our axis of symmetry will be at x equals 1. Okay. Now, for the vertex, we know the vertex has to be somewhere on that line. So we'll go back to our equation and we'll substitute the 1 in for the x to see what we get. So 1 plus 2 will be a positive 3. 1 minus 4 will be a negative 3. And that's going to give us a negative 9. So we have the point here now of 1 comma negative 9. Now again, notice here a negative 9 is not going to fit on my graph if I stay with a scale of 1. So I will adjust my scale. Okay, so we're going to erase that and we'll adjust the scale. So here's our X, here's our Y, and I'm going to go by 2. So this time I'm just going to label the 10 and the 10 here, negative 10 and negative 10 here, just to indicate that I've changed the scale. I'll go back and I will plot my negative 2, which is now here at this point, and positive 4, which is going to be here for my x-intercepts. And now my vertex will be 1, negative 9. So 1, negative 9 is going to be right there. That's my vertex. Now, because I already have these x-intercepts, I already have 2 of the 4 additional points that I need. So I really only need to find 1 more point and then reflect it to get the other point, and then I'll have all 5 points that I'm looking for. So I'm going to go with an easy one here. I'm going to choose x equal to 0. When I put that into my equation, 0 plus 2 and 0 minus 4. So I'm looking at 2 times negative 4, which gives me a negative 8. So the point 0, negative 8 is on my graph, which is going to be right there. And then reflecting through the axis of symmetry, I know there's also a point right there. And now I can draw my curve. Okay. Finally, if we take a look at standard form, the thing that we can tell from our equation in this case is the y-intercept. So the y-intercept is always when you put 0 in for x to see what the y is. Well, in standard form, if I put 0 in for x, it will eliminate my first term and eliminate my second term. And so all I will have left is my c term. So it always happens in standard form that c is going to be the y-intercept. Okay, so from vertex form, you can always tell the vertex from your equation. In factored form, you can always tell your x-intercepts from the equation. And in standard form, you can always tell your y-intercept from the equation. Okay. Okay, so we'll keep that in mind. Our y-intercept is going to be at 0, 5. But now what about the vertex? So the standard form is where the vertex is maybe a little more tricky in some ways, but still very doable. Again, the key to the vertex form is to figure out what the x value is in the point. And to find the x value, we take the negative of the b value and divide it by 2 times a. So in our equation, we have an a of negative 1, because notice that negative out in front. We have a b of 4. We have a c of 5. So to find the x value in my vertex, I'm going to take the opposite of my b and divide it by 2 times the a value. So I'm taking a -4 divided by a -2, which gives me a +2. So at this point, I know my axis of symmetry is the vertical line x equals 2. But now to find the vertex, I substitute that 2 into my equation. So 2 squared is 4. Make that negative because the negative's on the outside. 4 times 2 will be 8. And then we have the 5. Don't really need that parentheses there, sorry. Okay, so -4 plus 8 is 4, plus 5 is going to be a 9. And so we have a vertex now that is at the point 2, 9. So again, with a number like 9, we probably want to go with a scale of 2. So I'm going to label to show that I'm using a scale of 2. And if I go to the point 2, 9, that's going to be right there. That's my vertex. I know already that I have a y-intercept at 5. So 5 is going to be right there. Using symmetry through the axis of symmetry, I know then I have another point that's going to be right there. And so now I just need to, again, find one other point and reflect that to get my last 2 points. So looking at what I have here, an x that's close by, maybe I'll go with a, let's see, I don't want to get too tight in there. So maybe I'll go with a 6. Okay, so if x equals 6, then y is going to be -6 squared plus 4 times 6 plus 5. So we'd have a -36 plus 24, 24 plus 5. So the +24 and the +5 would be 29. Add that to the -36, and we would get a -7. So we have a point of 6, -7. Okay, so 2, 4, 6 is 3 lines out. 2, 4, 6, 7 means I've got a point right there. And then symmetry again through this x equals 2 line. Means that my other point would be right there. And now I can use my 5 points, draw my smooth curve, and there's my parabola. Okay. I hope you found this helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math page on YouTube. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.